Thanks, Vidhi, for introducing. Uh, I'm basically from Samsung Research Institute, and we are located at Outer Ring Road, Bagbane Tech Park. And I'm basically leading a software engineering team which takes care of developing automation tools based on machine learning and artificial intelligence, catering to the software testing and process automation. We also take care of quality assurance of some of the important technology areas like IoT or AI, basically on the mobile side. We are also taking care of the deployment of the process like Agile in the organization. So this is brief about our work. So today I'm going to talk about smart voice assistants, what goes behind these smart assistants, and how do we ensure the quality of these voice assistants. So how many of you use any of these, Bixby, Alexa, or Siri? How many Bixby? Okay. Alexa? Wow. And Siri? Cortana? And I think Google Assistant, everybody will raise hand. Okay. Okay. So when we use it, it looks very simple, but there is a lot of things which goes behind it, if you have to ensure the quality of these voice assistants. So as you know, like these days, the number of devices in our homes are increasing, So we have a television, we have refrigerator, we have, washing machine. All of these devices, right now we operate either using a remote or using, a UI or, some menu. So we have to go there and then select some items and, navigate through them. So as the digital mesh is increasing and the number of devices in the home is increasing, it is very difficult to interact through menu or, UIs. So voice assistant is a mechanism, through which you can have better interaction with the devices and more interactive way of, talking to them. So in fact, these days it's not good to call these devices as, just devices. They are basically your companions. So when you have to ask something to your companion and every time you go and press some button and then again press some button to do some job, that's not good. So you can talk to that companion, these devices are now your companions. So you can see that, what are the different use cases that can be, that have to be used with these devices. For example, you have a mobile phone, you go to your contacts and select, the person whom you want to call. So this is quite tedious. Instead of that, you just pick your mobile and say, call, John or James or XYZ. It's too interactive and too easy. And there are many features or, utilities which are deep embedded in this, in the UI mesh. So for example, if your mobile phone, I'm sure you might not be knowing all the features or menu paths, you would have never navigated it. But you would have certainly wanted to do many things, Suppose you want to get an IMEI number of the mobile phone, you have to type *#06 and then, get the IMEI number. Or you have to go to, phone settings, about device, and then, see what is the IMEI number. Instead of that, you can just say, show me the IMEI number of the phone, and you will immediately get it, So this is the power of the voice assistants. So typical use case can be, you're sleeping in the night and then you want to change the AC temperature. Instead of taking, something, you just say, through a voice command that, change the temperature of the AC or reduce the temperature of the AC or increase the temperature. This is quite handy. So these days, if you see, all these devices are also connected with each other. So, your fridge is connected to your television and your speaker is connected to your mobile. So in this multi-device experience environment, it is very important to have a mechanism to interact via voice. So I have a television in front of me. I am sitting in front of my television and I have a refrigerator in my kitchen. I can simply say, through a voice command, show me what's there in the refrigerator. And on the TV screen, I can see what all things are available in my refrigerator. So that is the strength of, voice assistants. This is the way the future is going to be, and then how we will be interacting with all these, companion devices. So this was actually a video, but it will not play? Okay. This was a very interesting video for Bixby. So Bixby is primarily from Samsung, a voice assistant from Samsung. And you can do a lot of things using it. So unfortunately, this is not playing here. So if you see, the recent market survey from Juniper, it says that, the voice assistant market is going to grow like anything. Right now it's around 3 billion voice assistants in use, and by 2023 it's going to be around 8 billion. And the biggest market segment using right now is the smartphones, and television is another area where the usage of the voice assistants is increasing dramatically. So before we go in understanding, how the quality assurance of the smart voice assistants is done, it is very much important to understand what are the important components of a voice assistant. So in your device, you just see a simple, you press a button and then your voice assistant is activated. But actually, there's a lot of things which goes behind it. A lot of things happen on the server, on the cloud. So if you see, a user can speak through any of these devices, like, he can give a command, voice command to his mobile, or he can talk to a TV or a speaker or, the smart watch. So when he does that, after that, his voice speech goes to the ASR. ASR is automatic speech recognition engine, and this sits basically on the cloud these days. And this engine basically converts your voice to text. So anything you speak is basically understood by your ASR engine, and it's converted to the text. So this text is then passed to the natural language understanding engine, which classifies and understands and analyzes what the intent of that dialogue is basically. And based on that, it takes some actions, and then a response is generated back in the form of natural language generation. And then it is passed to the text to speech conversion engine, and then a reply is sent back to the requester, or who is giving the command to the device. So if you see, this is a typical use case. Suppose I have a mobile phone, I have a voice assistant, and I say show pictures taken in New Delhi. So if I have to go, through the UI or the menu of the phone, it's a little bit difficult. You have to open the gallery, and then date-wise you have to scroll down, and then if you have the location tag, then you have to see which are from New Delhi, etc. But through voice assistant, you can simply tell show the pictures taken in New Delhi, and your ASR or speech recognition engine will break down into after understanding your language or your accent, it will break down into show pictures taken in New Delhi. And then this text is basically passed to the NLU, which is basically the brain of the entire system. And then, this NLU will understand what is the basic intent. Intent is to show pictures, and pictures from New Delhi. So then the appropriate action is taken, and the NLG, which is the natural language generation engine, will give a reply back to the user that, have a look at the pictures from New Delhi or something like this. So you see, how much easy it is, if you have to do the same thing using your menu in the phone, it's too difficult and it's not very interactive. So now let me come back to, the validation and the quality assurance part of it. So as I said, when we talk about voice assistants, everything is not in your mobile. In the mobile, you have a very thin client for Alexa or Bixby or whatever it is. Everything the rest of the things sit on the cloud. So for example, you have your ASR engine, which is running on a, on a cloud. So once you give utterance, it goes to the ASR engine, and then, a lot of things happen. So we have to individually take care of ensuring the quality of each of these important engines, which is primarily ASR and NLU. So when we say ASR, we have to, take care of the vocabulary. By vocabulary means, in a particular language, you will have a vocabulary. For example, if it is English, there is a different vocabulary. If it's, French, there is a different vocabulary. If it's Hindi, there is a different vocabulary. So this ASR engine should be trained and trained properly and trained enough with the right data so that it understands, that vocabulary of the language. So anybody who gives an utterance to any of the device in that particular language, ASR can recognize it and then parse it and then send it to the NLU. In ASR side, it is not just important, that we train it with the vocabulary. Accent is also very important, So if the accent are different, then, you need to train your ASR engine with different accents also. So the same sentence, in English, people can speak in different accent. So if your accent is different, the ASR can, fail. So it should basically understand all the different accent also. So we have to select, the people who speak in different accents, capture their audios, and then train this engine with it. ITN is primarily like, many times we say that you can give a command to your phone and say that, what is 25% of, 5,000. So when it goes to the ASR, it should go as 25 in numerals and percent of 5,000. So this also should be taken care properly, because if ASR doesn't understand this thing properly, then, it might not give the right input to the NLU. Homophones is something like, we have same pronunciation for different words. For example, TO is 2, TOO is 2, and TW is 2. So, based on the context and, some intelligence, ASRs should understand that what does 2 in this sentence mean. So we have to basically train our engine considering all these parameters. For that, we have to collect rich data set from the real users also. On the NLU side, we have to take care of the domain. Domain is primarily, for example, in the mobile phone, if it's a gallery or, call or, SMS, it's called as a domain. So when any utterance is coming, as a text from the ASR side and fed into the NLU, it should hit the right domain. So for example, I am saying call Jones, but it opens my gallery. So, such sort of combinations and other things we need to, validate properly and intensely. Intent is basically, what action it should do. So if I say take a selfie, so, that is an intent. So like that, we have to give a lot of inputs to the NLU so that we understand that whether the right domain and the right intent or action is performed or not. And dialogue, of course, is something, which is a response back from the NLU side, and through NLG it goes to the user. So in both ASR and NLU, latency is very important. So because this sits on the cloud, ASR and NLU. So if you try to use a voice assistant and, it takes a lot of time and then there is a lot of lag, then it's not user friendly. So we have to continuously measure the latency, how much time it takes, at each stage, right from the user giving command to any device like mobile or TV, how much time it takes to get a response from the ASR, from the NLU. We have to break down into various, steps and then measure the latency and finally see where is the actual glitch in the performance and then take corrective actions. So this is a typical example of Indian English. As you know, the Indian English is very complex, although it is English, but India is a very big country. We have people from, east, west, north, south. Everybody speaks English in a little bit different way. And also the vocabulary, on the north side, you have your film actors in the north and in the south. The names are quite, different. So if your ASR and NLU are not trained properly for those vocabulary, then your system will fail. So when you have to make your systems available with the Indian English, like, your TV should recognize your English language, or your mobile should, understand, your mobile voice assistant should understand Indian English. You have to train with a lot of vocabulary. So you have to train it with the city names, celebrity names, different places like Agra, Delhi, Chennai, etc., lot of things. And also the shop names, singers, etc. These are just the examples, but there are many more things that we need to do to train the engine. And this is about the language model and the vocabulary part, but accent is also important. Same sentence in English is spoken in a different accent by different people in India. So especially implementing this voice assistant solutions in India is a little bit difficult because primarily of the accent part. Our accent is too diverse and people speak in wide variety of accents, So this is really a big challenge for us, So when we have to, train our engine, we have to take voice samples, a person from Karnataka, the same sentences, like, 5,000 sentences, how he will speak in English. The same 5,000 sentences in English, a person from, Kerala with a Malayalam accent, how he will speak. So all those things are taken and their voice samples are collected, and then, your ASR and NLU engines are, trained properly to take the right response. And then, you measure the accuracy, of your voice assistant engine, categorizing into north, south, east, west, and in south also you have to categorize, by your states or other linguistic basis. So this is a typical test environment in which we have to ensure, we test enough to ensure that, the ASR is of good quality and its response is good. So if you see, this is an automated system that we have created where we have a master controller here. That is through, your laptop, you can control your various devices. So when you talk about ASR, you need to take care of, different voice samples, as I said. In that also you have, different age groups, same sentence, an elderly person and, a teenager or child, they will have a different way of speaking an accent. Gender is also important, same sentence with different genders, you need to train your engine. Most of the places we have a lot of noise, so how our engine is going to operate in a noisy situation. So we have to, test it, where we have a lot of noise. So how does the ASR reception is there, and whether it understands or not, properly. And of course, suppose these days, many of you might be using speakers in your home, like, AI speakers, where you just tell something to the speaker and it does some action. So that the speaker might be lying like this, in the projector, like the projector somewhere centrally in your home, and you can give any commands to it. So it does matter, at which distance you are talking to it and which angle. So while, validating, the engine accuracy, algorithm accuracy for ASR, we need to take care of all these things, whether it's from 1 meter, 2 meter, 3 meter, and, different angles, 60 degree, 30 degree, So because practically if you see, many times we get issues with particular distance and angles. So those need to be sorted out if we have to make our solution of a commercial quality and of a, more user friendly. So coming to the end-to-end quality, we have seen that, the individual component, how we test ASR and NLU and how much data we need to prepare to validate the accuracy of the algorithms, etc. But end-to-end is the complete system. Like as an end user, you use voice assistant, right? So it's like that. So what are the things you need to take care when you do the end-to-end testing or quality assurance? So as I said, individually you check, with different vocabulary, accent, etc. But finally, when you test the system, you again need to prepare a different data set and, check your system. So for example, different vocabulary and acoustics and pronunciation based on gender and age group. Test environment conditions like, in your office, in your home, in public places, how your system is responding, how your voice assistant is responding. So you need to take care of all those conditions before you launch your voice assistant commercially in the market. Listening and security, like, many times you have, false wake up. So you have not triggered your voice assistant in your device, but somehow it has triggered. So we need to take care of those things also. I think you work on this area, no?
I have Alexa at home.
Oh.
And the Alexa ad comes on TV, it starts taking it.
Oh, right. Okay. So, and false rejection also, sometimes you say something, but it's not taking any action. Multiplicity of vocal inflections, different people have different pitch of talking, so that pitch also has to be taken care, when you speak something, in different pitch or frequency, And voice samples, validation across demographics that I already told, So for example, if you consider just English language, so English language in India is so complicated. It's in US people have a different accent, British have a different accent. So, making this voice assistant just for English language itself is very challenging because, there are so many parameters, involved in it. And imagine, now if we have to extend these voice assistants to other languages like French, German, or imagine, we have the local Indian languages like Kannada or Bengali or Hindi, it's really a challenging task. So you need a lot of good data to, continuously train your systems and engines so that they become more and more accurate and user-friendly. So on the NLU side, what is more important is, context-based learning. So depending on the context, the NLU should be able to decide, what is the basic intent of the user. So previous context, it should also understand. So we need to validate it from that angle also. And one of the best ways to ensure, that our system is foolproof is to do some beta testing. So with limited users before going full commercial. So that is the place where you can get the real user data and real issues. It's related, whether it's related to your ASR, your speech or accent, or also, whether you have supported all the utterances which the end user might be looking at. So this is very useful. On the NLG side, which is the natural language generation, you need to take care of the quality of the dialogue content, how the response is going to the user. Is it of good quality or not? Or, some other messages goes, which makes the user annoyed. And also handling error scenarios, because everything might not be supported. Whatever user is asking to the device, there is a possibility that, something is not supported by the voice assistant. So whether that thing is handled gracefully, whether a good reply is given back to the user, which is, user friendly and soothing, not annoying. So such sort of scenarios also we need to, check. So this is also very important thing like big data. So after you make your voice assistant commercial in the market, and when it's launched and, millions of people are using it, you continuously get a lot of data in your servers in the big data, right? What is the utterance given by the user, and his speech also, voice accent and then voice samples keep coming to the server. So we have to continuously see, we have to have an automatic mechanism where we continuously see what has been coming from the user, what is his expectation, and whether it was addressed by the current system or not. If not, we have to continuously train our system, because most of the things sits on the server, so you can keep, updating your servers and for ASR and NLU, so that without impacting the user in any way, you can upgrade and, improve his, scale up his performance down the line. On the UX side also, we have to take care about the seamless experience from right from the speech which is given by the user till he gets the response. So overall user experience should be very good. And especially in the multi-device environment where you have so many devices connected with each other, so this becomes all the more important. So we have to check all these and do a lot of user trials to see that, whether our UX and then response is good or not. So that's all about, the end-to-end quality point. So, as I mentioned, some of the challenges already in the course of my speech, but some of the important things we need to take care going forward are like addressing the security and privacy concerns. So down the line, if most of your devices operate through voice commands and you have logged your device and password, so when you give a command to the device, there are security concerns, there is a possibility that, the device, somebody might use your password or to open the device, So these are some of the concerns. Privacy is also important because if it is a false wake up, right, you have not told anything, you have not waked up your voice assistant, but it's somehow waked up. And it's continuously, passing your data or speech to the server, So that's about the privacy. So these are some of the important concerns that need to be addressed more rigorously down the line when the usage of the voice assistants increase more and more. User personalization, like, right now everything sits on the server side, like ASR and NLU. So even though we try to optimize the latency, still it takes some time. So based on the previous user data, how he has used the voice assistant in his mobile phone, for example, we can personalize it so that, whatever he has used earlier or he is using frequently can sit on the mobile side itself. We can train, and then, that ASR component that is an embedded on-device ASR or an on-device NLU. A small component can sit in the mobile side, and then, it can give a better user experience by reducing the latency. We have already discussed about the complexity of languages and accents and different distance and angles which need to take care. Multiple devices from the same provider. For example, if suppose Samsung is giving, your washing machine, TV or mobile, and you use the voice assistant like Bixby. So, in the multi-device experience environment where you have so many devices, when you're giving any command, you don't know where it will go, right? So that is a big challenge. So which device should take that command? Operating in noisy conditions, I have already told about it. This is very important, especially in the India, because, if you go out from your office, you can see a lot of noise around. So this is very important, specifically for such markets. Ecosystem from all, this is Bixby? Oh, no. See, this is Bixby in my mobile. It's a Samsung mobile, so I said Bixby, so it waked up. Okay. So ecosystem for all OEMs for devices connected. So down the line, you will have devices, in your home, you can have device from one device like refrigerator from LG and TV from Samsung and, a speaker from, XYZ company. So, in that environment, if you have voice assistant, then how you can talk to, different devices. So that is also challenging, and that might be a need of the future. Last but not the least, right now, if you see the NLU or the ASR, it has been trained with more than 60,000 skills. Skills means, it can do 60,000 different operations. But when we see the real usage through the big data, the usage is not so much for all the 60,000. It's like very few utterances or few commands only are being used by the user. So it means that, it has not deeply penetrated into the consumers as of now. But you can see the trend, down the line, everybody has to, go towards that, because as the technology of voice recognition is improving day by day, and the accuracy of the systems is increasing for the NLU and ASR, down the line it will be more and more accurate and more comfortable to use such voice assistant. So that's all about the smart voice assistants. If you have any questions, I'm happy to take. Yep.
Thanks for the talk.
Yep.
Do you see visual input, like camera-based inputs, getting integrated with audio-based assistants, or even other sensors?
Uh-huh.
They can, in combination, solve some of the problems, right?
Maybe down the line, but as of now, trend is not there right now. But we don't know about the future, Everything is getting integrated, Yeah.
Hello.
Yeah.
So how we will solve the, as a QA, how you will test these scenarios?
So as I mentioned, I break down into various things, right? How you test. So you need to prepare a rich test data. So the data set has to be prepared with the users, So if it's ASR, you need to have people from different regions speaking Punjabi, or, if you are doing for English, you have to get people with accent, Punjabi accent, Malayalam accent, like that, and then capture their voice. And then feed it to the ASR engine and see how it is behaving. So this validation is primarily based on the rich data set from the users. Yeah.
Okay, so you do it in an automated way, or?
I think doing it manually is really impossible. So we have automated ways which we have developed in our organization.
Okay,
So where continuously you will have, your thousands of voice samples, one by one that will be fed to the ASR, and you will see the accuracy of the ASR, and you will get the automatic reports.
So you test individually each of the components, or end to end you will see the results?
Individually in the start, and then finally towards the end of the product life cycle, fully, like a user. So testing individually is also very important, because you cannot just test fully end to end. You will not get all the issues, because these are the systems which are based on training your algorithms on a systematic and continuous basis. So you have to continuously feed the data, see the accuracy. If it is not in line, then you feed in more data, improve it, and then go ahead. So individually as well as finally end to end.
Yeah, thank you.
Repository of all of your data samples, and how is it like over a time it will be like a closure?
Mhm.
For example, if you are keeping all your data sets for learning that, and
Mhm.
over a time it may be like you have a 1 billion people sample there.
Mhm.
How you are going to optimize or manage that data set so that
Actually, when you have a data and you feed into a system, right? And you will see the accuracy of a system has improved. So down the line, you don't need the data, because you have already taken care and improved your algorithm based on, say, 100 data set. Then you need to take a new data set, and then train it again. So regression issues are there, but not so much, because it's.
Usually you said that, okay, we are using automation, obviously, manually it won't be possible
Yeah.
to test this much. But when we are going to use automation, obviously this is a kind of regression. Basically for regression.
Yeah.
And if we are saying that, okay, we are going to remove our test beds or test bed, then obviously we will run into regression issues. If we are going to put the same data or put the previous stages.
Yeah, because you have, when these sort of systems comes, your data management also becomes important. So down the line that this was the data I already trained my algorithm on. And when you get some regression issues from the market through the big data system, you have to again train it. So it's a continuous process, So it's not that, you don't have to do regression, you have to do regression also. Any other question?
Hi.
Yep.
Hi, Dinesh here. So you mentioned about different attributes of testing, like language complexities and accent and all those things. Is speed of input is also an attribute for testing here? Like different people speak with different speed.
Of course. So as I said, in one of the points, vocal inflection, the frequency of speaking, how fast they speak, and what is their pitch, all those things should be taken into account.
Thanks.
Yep. Yeah.
Interact. Yeah, Sumit here. Where he can interact to all the devices which belongs to Samsung, like Samsung TV,
Yes.
Samsung refrigerator?
Of course.
It
Yes,
has, right?
Yes.
Oh, good, thank you.
So that's what I gave an example, right? You are sitting in front of your Samsung TV and you have a Samsung fridge in your kitchen. You can ask your TV, what is there in my fridge? So you will see on your TV screen what is inside your fridge. The prerequisite is that you should have a smart fridge from Samsung,
Oh,
Yeah.
Good, thank you.
which has a camera inside it.
Yeah.
But it is possible through voice assistant. Yep.
Is there a standardization process, like now we have Google, Samsung is there, Apple is there, so all of them have their different sound systems. So will it be like possible for IoT we are doing, standardization is going on, like similar kind of standardization is going there for
Standardization in what terms? Like,
ASR? Basically, if I said for Alexa,
Uh-huh.
it can be used for Samsung.
yeah, that was one of my points. Down the line, suppose you have a device from Amazon and one from Samsung, then, interoperability between those. So that is the future challenge, as I mentioned in my last slide. That is the future challenge that needs to be looked into. But right now, it's not possible because each company has its own ecosystem to, address these things. Yeah.
Can you throw more light on the training of domain-specific questions to a chatbot or a voice assistant, please?
Sorry, can you come back?
Yeah, the thing is, there will be domain-specific queries that come in, right? So how are we going to address that? Can you please?
So
throw more
domain
light
is specific in the sense if you talk about mobile,
on- Yeah.
so domains will be like, your gallery, your call, your SMS. So, when you talk about gallery, you have to generate all possible sort of utterances which a user can give as a command, for the gallery domain. So you need to list down all that and then, do that. Did I answer your question or you meant something else?
Yeah, that is.
Okay.
Thanks.
Yep.
What application or software or framework do you use to test this?
This is proprietary developed by Samsung. So we have an automation team who has developed a test platform for voice assistant. So this is internally developed by Samsung. So as such, I don't see anything which is available freely in the market or you can buy something as for testing the voice assistant. Each of the organizations have their own test setup.
This is common, for an organization, it is a common framework for all devices, or again, it depends on what device you are testing?
Actually, when we started, for example, in Samsung, it was mobile primarily. Now we have TV, we have refrigerator, we have AI speaker. So now it's all together also. So as I showed you in one of my examples, right, in one of the slides where you can, this one, right? So you have various devices in the center, right? And then you can, validate all of them.
Okay, thank you.
Yeah.